So I'm going to try to solve this question matrix median given a 2D array matrix that is row-wise sorted. The task is to find the median of the given matrix. So it's a good question. So we could simply do this by adding all the elements to a single array like this and then finding the median. But it would take a good amount of time and complexity. So we are going to try and optimize that by binary search. So what can we do is make a binary search approach which finds the number. As we know that the median is between the uh, is in between the length of the array. So if, for example, if the length of array is 9, the median will be 4 elements after and 4 elements before. So we could simply use the fact that the median is after 4 smaller elements. If the size is 9 and if the array size is n, then it will be something like n by 2. So as the number of elements in this is rows into columns, we can simply use that fact. So firstly defining int low equals to int max and int high is equals to int min. To define the clear low and high, we could simply use a for loop for int I is equals to 0, I less than so let sorry int m is equals to the number of rows in the matrix. So matrix dot size and nb int n is equals to matrix dot 0 dot size, which is the number of columns in the matrix. So int I is less than m I plus plus, and we could simply reassign low to low is equals to min of low and the current minimum in the matrix, which is matrix always have like it is sorted, so it will always have between 0, 2 and 3. That is the first column of all the rows. So it will be the 0th column and mth row, whereas the high will be always the last element in the rows. So it will be high is equals to max high comma matrix 0, sorry 0 not 0, it is the number of rows are m, so it will be wait a second, into I and minus 1. Okay, then we are so sorry, I had like a error in judgment. So this will be iterating over all the rows. So I here in the 0th column and I here iterating over all the rows and n minus 1 the last column here. So we can simply calculate the required by doing this. Int required is equals to n into m, which is the total size of the elements divided by 2. While left lesser than equal to right, we can do if firstly we can calculate the remaining required elements. Int remain int smaller is equals to define a new function, count smaller, count smaller mistakes in the arguments, the matrix, um, the left, the right, and so it takes in the firstly we can calculate the med and med is equals to left plus right by 2. Then we can calculate the small count smaller, takes in the argument matrix M and the middle element. So we could simply do this if smaller um, if the low is lesser than equal to the smaller, we could change the low to something greater, which is made plus 1. Else, we could change the high to something like if the number of middle elements are greater, we could change the higher to high minus mid minus, and then we could simply return low at the end. Then we could define a function in found smaller which takes in the argument vector and breaks the and line break. So firstly let this initialize the count to 0 and then continuously iterate over all the rows for int I is equals to 0, I less than m, I plus plus. And we can simply find the element in the row. For example, our current weight is something like left minus right, something like 4. So we need to find all the elements lesser than 4 or equal to. So we could do something like this. We will count 1 and 4 from this, 2 from this, and 3 from this. That gives us 1 plus 1 plus 2, which is 4 elements lesser than 4 is lesser than equal to 4. So count plus equals to upper underscore bound of the matrix I, comma, element we have in mid. So that's it, and we will simply return the counters. Okay, so then we could do int upper bound takes in a vector in an array and int mid. So calculating the upper bound is pretty simple. So we can do int left is equals to 0, int right equals to array dot array is the last element. So array int and array. I think this is was and minus one is element, then if while left lesser than equal to right equal to mid equals to left right. Right. If array down mid is equals to, so we will repeatedly defining, so we will instead define something like x array x array uh, uh, lesser than greater than equal to array of x, we could define and so is equals to n minus 1. It should return, no, simply not return answer is equals to mid. Fucking hell, bro. So I was kind of right and not right. So else, moving forward, we could write else left is equals to mid plus 1. So we could simply return the answer which is n, and if it is n, there is no upper bound. While left or right, mid is updated. If array of mid is any time greater than, we update the answer to mid, semicolon, and the high is reduced to mid minus 1. Else, if the array of the mid is lesser than x, then we could simply do left is equals to mid plus 1 to use the left side, and yeah. And when this loop is over, say we can simply return the answer. So when the upper bound is returned for each matrix here, the count is increased, and the count is increased. So int I from I to n to, we return the count, and the count is used here. While it is smaller, low is plus mid plus one and high. So kind of it converges to the correct answer, which is the median. So let's try if this is working fine. Your experience I haven't tried it. Well, we'll try again. See what is the compilation. Okay, this seems bad. The 11th line. Uh, upper bound 5 was not declared in this book. Alright, I guess it was right. Let's try again. Gain a compilation array. Mid was not declared in the scope. In mid. Again, please and bro. Please. Fucking crazy. Did you mean count was not included? Okay, fuck you, code. And I think I've exhausted my free tries. You please run. Oh, fuck you, tough plus. Fuck you, motherfucker. I think we're done here, and the time complexity will be something like we are using this for the calculation. So log n for this, log n for the upper bound, and n for traversing all the rows. So boils down to something like n, a number of um, columns into log n of into log n. So n into log square something. Yeah.